All right, good morning, everyone. Welcome to the second of our seminars for the capstone Internet of Things. And why isn't it going to the next slide? Right, there we go. Could you please note that these meetings will be recorded, and posted to YouTube, so you can watch them if you missed them, or if there was something that you wanted to reference again later on, you can. Um, I'll put the links up in the discussions as soon as they're available, usually within a day or so of me going through editing out the silences and a few little bits and pieces. This morning, we're going to be running through the requirements for the next 2 weeks because these are only run every 2 weeks. And talking a little bit about the further assessments that we need to have done in the future, just to give you some idea of what's coming up and what we expect from them. All right, I haven't seen too many emails come through. Last week I mentioned if you do have an issue, there's several ways of contacting us or getting assistance. The first way is discussions, because the peer support you can get from the discussions is really important to the course. We have lots of different people in the courses, lots of different areas of expertise, and quite often you'll find that you can get one of the other students who has expertise in an area you may not to assist you with your project. So an example of that is you may be a gun techie, you know all about the electronics and communications, but you've never had any real business exposure. But lots of other people in the course will be business people, not techies, and they will be able to help you with the business aspects. It's one of the nice things about the course, Murray. We like to try and get people into teams, and I'll talk a little bit about that in a sec. Just so if you're working in a similar sort of area, you can collaborate with each other and get some help when you need it. On the point of collaboration, collaboration is good, plagiarism is bad. The difference is only claim things that you have done when you're writing your reports as your own work. And if you've got a solution or some other piece which fits your project from somewhere else, acknowledge it. Nobody these days works completely on their own. We all build on work other people have done. So that is expected, and that's in actual fact best practice. You build on what other people have done. There's no use reinventing the wheel. So just bear that in mind when you're writing things. Don't be concerned that you pulled together 20 different pieces from other people's work and you put them together for your project. That is actually one of the best ways to do things. Just acknowledge what came from other sources. If you reinvent everything yourself, you're just wasting effort. Okay, so we want to make sure everyone's in teams. If you're not, type something in the comment and we'll get to you in a second. I'll also mention that if you could make sure you're muted during the bits where we're talking or when you're not talking, it makes the recording a lot better and easier for everyone else. You can use the raise hand function in the chat or type your question in the chat, and Savash will let me know when somebody's done that because I can't actually see it when I'm in presenter mode, and we'll get on to your question. It's early morning, need coffee. Our Colombians should understand that. It's Colombian coffee. Okay, so what we'd like to know now, if everyone has a name for your device or solution. This is actually a really important marketing and development area. Having a descriptive, catchy marketing type name is more important than most people realize. It gives focus to the device. So our silly example we used throughout the course was our snoring solution. And calling it a technical solution for the reduction of snoring and better sleep for your companion probably isn't the best way to describe it, right? It's very hard to get the idea across, whereas something like Snore Stop, it's there. You know what you're doing. And it does help with the focus on the project. So having a good name, and if you could actually, if you've got one, type it in the comments now and we'll have a look at those. It does actually assist in the focus in when you're developing things. Okay, so this fortnight, the work is work on your Canvanizer, find the top 3 problems your IoT device will address, And it's very important that you limit the number of problems that you're going to attempt to solve. In engineering, probably got a fair few engineers in this group, we have a problem with something called scope creep. And if you don't tie down the requirements of your product early on in the design phase, you start to think, oh, this will be a good idea. Let's add that in. Ah, here's another good idea. Let's add that in. And product becomes, number one, bloated. It'll never be finished, and it'll not do any of the things you intend in the first place properly because your effort is too broad. So good idea is to focus on up to 3 problems that your device will solve. If it's only aimed to solve one particular problem, that's great too. Just make sure it does it really well. We need to start looking at our customer segments. This is the target customers that are specific to your IoT ideas. If you're working on, let's use that hot water system, safety and hot water usage monitoring, using those instantaneous heaters that are on the shower head, the target customers will be consumers, and consumers who have these particular heating devices in their showers. Now, there needs to be something called a unique value proposition. This is a single compelling message about why your IoT idea is different and worth buying. Absolutely crucial to the marketing. What makes your idea better than everything else? And it may do everything else the same. It may not do other things quite as well as other existing items, but there is one reason that you would buy this in preference to anything else or install it in your premises. And that's critical because that's the main thing you're going to focus on in the development. Remember, at this point, we're only really talking about creating a prototype or a framework of an idea that can be further commercialized later on. Bearing in mind, and I don't know how many people here are business and how many people are engineers or programmers, that if you are a business person and you really don't think you have the technical ability to create a fully working prototype, that's also perfectly okay. The idea of this course is to give you the knowledge so that you can talk to the engineering personnel, know what is possible and what isn't possible, and explain your requirements to them in language they understand. This also works the other way around. If you're like most of us on the faculty staff, you're a technical person. You don't understand business. You don't understand business all that well. You can build a wonderful technical product, but have no idea how to bring that to a commercial phase. So your project can concentrate on the technical development, while the business persons will concentrate on developing a commercialization strategy and market analysis so that they can specify things to the engineers who have the capability to actually build it. So either version or a combination of those or somewhere in between is really what we're after at the end of this course. Also, you need to look at the solution. What are the top 3 features of your IoT idea? The shower one looked at water usage, power usage, and maintaining a constant water temperature. And the unique value proposition of that one was it won't allow the water to overheat. So if the water flow drops, it reduces the current to the heating element so that you don't actually scald users of this type of shower heater. A critical one, and this is one technical people tend to ignore, is channels, the paths to customers likely to use your IoT idea. How are you going to get your idea out to the customers? How are you going to advertise it? How are you going to let people know that the device is available and what the benefits are so that they will actually buy it? And there's many, many segments, and we'll look at a couple of examples of that later. Revenue streams is another area. This is, again, critically important, as is the costing, and we'll talk about costing in detail. Nowadays, there's lots of different ways of looking at your revenue streams. Back in my business days, because I did actually have manufacturing businesses, worked in manufacturing very early robotic systems. They look really primitive when you look back on them now, but they were cutting edge. I could only sell this equipment by approaching individual manufacturers that would buy this equipment, which limited my market basically to my own state and to a smaller extent Australia as a whole. It was very difficult to market to anywhere outside of Australia. Now, with the development of the interwebs, a small business sitting, again, say in Colombia, can sell their product anywhere in the world. So with that shower heater idea, or the monitor, the gentleman who invented that could easily find out what other countries use a similar device, what power they use, how they could get it fitted, and market directly to end users in any country in the world. So it's very important to look at your revenue streams. Do you need to approach individual customers, the end users? Is yours a business-to-business solution? And if so, how can you contact those businesses? How can you get your product known to them? Or is it a wholesaling business where you want to find other people to go out and sell it for you? So that's another thing we'll be looking at, and it's part of our documents that we're creating at the moment. A very important thing in any product development is to develop some metrics to measure if you succeeded. So we need to create some measurable milestones. So these are things you can actually put a value on and say, yes, this worked. Now, there's a very interesting new way of thought around now. We don't aim always to have products successful. Because we've got the ability now to really rapidly produce things in prototype form, and we can do that at very low cost with 3D printing and off-the-shelf components, failure is not a big thing like it used to be, nowhere near as big. So people are now saying, fail fast and fail often. And the reason this is, it gives you the opportunity to try many, many different solutions. So when we talk about fail fast, fail often, we mean, okay, this is a great idea. Let's knock up a quick prototype, do a proof of concept, much like we're doing in this course. See if it's got potential. If it hasn't got potential, or there's insurmountable problems that we're going to have, we're in lockdown. So I'm working from home, and that was my tiny little Great Dane tiptoeing around. Excuse that, please. And it's not going to work. Well, we cancel the project and we move on to the next one that's got a better chance of success. So it's a new paradigm that people are working to, and it seems to it opens up a whole range of options and further developments people can do. It's a very interesting way of working, and a lot of the very large companies that we work with in Perth have adopted this in their research activities. And it doesn't mean you commit a great deal of money. Okay, unfair advantage. We're really looking at key advantages of your IoT idea. Things like, can it be copied? If it can't be copied, that's an unfair advantage and a good thing to be working on, and an excellent way of approaching people like venture capitalists to gather some money. And money is really important if you're going to commercialize this. If you're thinking of commercializing, let us know, because we've got a few contacts in the commercialization area, and I'm hoping that one of our commercialization industry people will come in and give a bit of a chat to us one of these mornings. Okay, so gone past our Canvanizer. Here's our Canvanizer. This is one I think we used earlier on in the course, and it shows basically how we can take those bits I had on the list and put them into a form. This is an accessible item for you, so we need you to complete this. And it's a living document. By that I mean, once we've written this up, that's not the end of it. If you think of other things that are relevant, add them in. It'll be a key part of how you write your final report. By using this Canvanizer to create a structure for your final report, which we'll give you an example of anyway, or a partial example, you can use this document to actually ensure that you've kept track of everything, that you know what you need to say in the report, and help with that. Okay. I don't think I want to go through every bit of this. This you can look at it the video when we go. It's got a few examples there using our snore stop example IoT device that we've used through the course, and it lists a few of the other things that are in there. We will be going through things like the cost structure, revenue streams, and the sales channels in one of the later, I think one of the later, or could even be this one, seminars that we have. Okay, you'll need to be doing or starting work on your market research and costing plan. The purpose of this plan is really to consolidate your own ideas, use your document you produced. Oh, I forgot the name of it. I said it. Use this document to create the market research and costing plan. So your Canvanizer, again, it's a useful tool for helping build other documentation and keeping track of what you're doing. There's some key decisions you'll need to make before you can complete this plan, such as determining your business structure and what demand for your products or services there is. Now, your business structure is also crucially important. And again, we go through this further in the costing that we talk about a bit later on this morning. So I'll leave it till we get to that, in fact. It's important you know the industry and the environment your business will operate in. Use the internet to gain the keywords and themes for your IoT product. And patent searches is a really good place to look for other innovations. This is going to help with working out what market competition you're going to have. For instance, if you find out that someone like Apple has already produced your IoT device, you're thinking of, say, those tracking tags that Apple's just released, you might want to either rethink going into that market because Apple has reputation, marketing expertise, they're very well known and extremely hard to compete with, like many other companies. Microsoft's another one that's hard to compete with. But if you do find that there is somebody out there large, well-established, that you're going to have to compete with, it goes back again to the unique value proposition, right? This one here, that allows you to compete even against very large competitors. If you have something unique that you can highlight that will solve a niche issue, excuse me, it's still worth continuing, but you have to be able to identify that and identify it well. So know the industry that you're working in and have a look to see what's already existing. Google's great, but look at the available patents. In Australia, we've got a patent site that allows us to look them up, and also Google Patents. Patents shouldn't stop you from using other people's ideas. The patent system was actually invented to help you use other people's ideas. But unfortunately, in some countries, it's used for exactly the opposite purpose. If you do find a patent that is useful to you, you can always negotiate with the patent holder to license that technology. Okay, market research, industry analysis. This is also very important, and in different countries, very different environments. We have political influences. You need to identify the political and legal factors that may affect your business. If we look at an IoT device that you intend to put into the medical industry, that is a highly regulated industry. It will take you years and years and years to get approval to use it. That doesn't mean you shouldn't do it. It just means that you've got a much longer lead time to getting into production and gaining the revenue. So you need to look at alternative plans to fund your business until you can get it out into marketable form. In some areas, politics affect whether you can have something. If we look at the Chinese market, there is a strong government hold on things that deal with information. So you would have to ensure that you're not breaching any of the local laws on information availability and how people can access that information. So just be aware of your own political situation and the political situation in countries you intend to sell in. This is fairly obvious, but economics, you've got to look at some of the economic factors that could affect your business. Exchange rates, they're a big one, particularly in Australia and other developed countries where our currency is relatively strong, which means if we manufacture within Australia, we've got very high labour costs and we price ourselves out of the market in many other environments. Interest rates, access to capital, availability of labour, location of manufacture, import-export rules, all those sort of things you need to be looking at on the economic side. Social, this is one that isn't thought of very often. sometimes there's issues in the social and cultural factors that may influence your device and whether it can actually be successful in particular countries. I know in some of the Middle East countries that we are not allowed to show certain images, so a video system may impact the cultural issues showing individuals. So again, you have to be very careful of that. Looking at population growth, so if you're looking at an aging population as the main users of your IoT device, developed countries are really good for that market because we have an aging population, whereas some other countries don't have the same issues in the aging population. The life expectancy is not as long, or they have a cultural, again, going back to the cultural side, a cultural tendency for families to look after their elderly parents. And that means that there isn't a need for elderly people to live independently as much. One of the obvious ones in our situation is the technology. What are some of the technology factors that could affect your business? Advancements in the way things are changing, processing power you may start developing now, and your processing demands can't be met, but they will be in the near future. So you need to be able to understand what the technology roadmap is for your particular requirements. So that means looking ahead towards where you expect the device would be available to the majority of people. So if you're looking at something that requires a fair bit of edge processing, a rather large amount of memory, don't look at the devices so much that are available today. Yes, you need those for implementation, but when you're looking at the commercialization, go to the manufacturer's website and look at their roadmap. And they will say, we have a chip which is going to be twice as fast, have twice as much memory, and it's going to be available in mid 2024. You can design for that specification, but use the current technology. So always be aware of how the technology is changing. And of course, industry. What are the current What are the current and future trends affecting industry? Again, this is critically important, particularly in our field where we're dealing with the IoT Industry 4.0 and a whole bunch of other buzzwords. It's changing very, very fast. We've got miners and process companies that are extremely traditional. They're still using equipment from the 1960s. So this equipment's 60 years old and it's still installed and it's still running, still being used in the processing of things like aluminium and other minerals. They're very hesitant to change, but they've started to realize now that there are many, many benefits in moving into the industrial IoT, Industry 4.0, and automating their systems. And they are starting to move into those high-tech areas fairly rapidly. So if you really wanted to get in the early stages, get into the ground floor, you look at where these industries are heading and try to meet the demand for a couple of years' time. So be very aware of what your particular industry is, where it's heading, what the resistance is to new ideas, and those sort of aspects. All right, I don't want to talk too much longer. I might actually cut out some of this presentation. We'll run it next week because we really do want to be able to talk to you and have the introduction. So I'll do another 5 minutes, but then move some of this off into next week. Okay, a bit later on, we're going to have to be doing, very soon, we're going to be doing the market research and costing plan. Here's an example of how to lay out your competitor analysis and the market research plan. Pick a competitor. If it was Apple Computers, we'd put them down. When they were established, so are they long established, or are they also a fairly recent developer in the area? What sort of products they do based on what competes with you. And we've got a very, very good example, and I don't know if Ellen would be willing, but one of the small startups that came out of Curtin produced some earbuds, like you would normally have for listening to your iPhone or listening to music, except they thought they could do a little bit better. And they produced it so that it is hearing protection, so it will cut out noises above, I think, 100 decibels. It's fully adjustable for your hearing condition. So it became a hearing aid, and does all of the normal Bluetooth functions that people expect of earbuds. Because they managed to develop this, and they are not a hearing aid company, and they are very, very new, they can produce these hearing aids for 1/10 of the price of commercial hearing aid companies. You don't need an audiologist to install it and configure it for each individual user. People do that themselves at home, and that reduced the cost massively. So we have the case of a very new company starting up against very well-established manufacturers who have very well-established marketing strategies through audiologists and doctors, and they are extremely successful because they go direct to the end user and say, do you have a hearing problem? Do you want earbuds? We have the solution for you at 1/10 of the price of what you would normally pay for a standard hearing aid. So just because you're new to the field doesn't mean you can't get into those markets. And they market this directly through the internet. They do very little direct sales. They have one shop in Perth that sells their devices, but that's it. And everything else is handled through alternative channels. So here's an example of something that uses a unique value proposition, a very, very strong one. They use different sorts of marketing to traditional markets, and they have become very, very successful. And they sell on a global scale and very high numbers. And they're just a very little company that sits pretty close to Curtin in a backwater town called Perth, Western Australia. One of the other things to look at is your percentage of market share. Do you think you will own the market? Is your thing unique? So you need to know how much of this overall value that is in your product range that you expect to capture. Again, the unique value proposition that you have. They have. Sorry, I made a mistake on the market share. The market share should be the competitor's market share. So if you're looking at competing against Microsoft, it's still a 90% market share. It's going to be very hard to break into. What are their strengths and weaknesses? So these are the sort of things you need to look at for your market research and costing plan. Okay, I think we can get through this one. All right. There's a good website I found about marketing, how you can market your products. One of the key issues, and there's probably only one I'll talk on this and may bring a little bit more up next week, is what is your device for? Is it there to make a profit for you, which is perfectly legitimate and a good way of doing things? Or is it something that's there as a philanthropic, good for the community, something you want to get out there to help the world? Also something that's worthwhile. And when you're working out your costing, you need to bear that in mind. If you're doing it on the basis that you're here to make a profit, you need to recover all of your costs, including the cost of this course, all of the hours you put in. You need to allow for that within your costing structure. So even though the device itself may cost you $10 to produce, you wouldn't want to sell it for $13 because you put a lot of time and effort into developing it. You need to make a reasonable profit, and you need to make enough money to be able to continue to support your product. If you put a product out there, then just disappear, you'll never sell anything ever again. You need to have the money to release version 2, to cover the warranty and repairs that will inevitably happen. You need to cover your building costs, your overheads, management, accounting systems, pay the tax man, and a whole range of other things. And this needs to be built into it, whether or not you're doing it as a for-profit or a philanthropic. With philanthropic projects, you tend not to include your overall development cost. You say, right, that's my gift, I'll do that for nothing, so you don't try and recover your R&D. But you do need to have a profit in it. If you're doing things for a philanthropic purpose or for a not-for-profit, that doesn't mean you don't make a profit. It means that you return the profits into further development and support of the product that you're producing. So you need to have your cost plus pricing in there to be able to continue to offer this service to your philanthropic market in the future. But we will talk further about this more later on. And the next thing is you need to do a SWOT analysis. SWOT analysis, this is where we start to become realistic. You really need to look at the strengths, weaknesses, opportunities, and threats. SWOT analysis has been around for a very long time. There's lots of newer methods, but they are a simple way of looking at how to approach the development and marketing. So in this example, we're using Apple as our competitor. What are their strengths? Awesome interfaces, one area where it's head and shoulders above the rest, easy to use. If I want to make a phone call on a phone, I would use a Apple iPhone. If I want to develop an app for a phone or do something really clever with a phone, I'd use an Android because it's better to develop on. But Apple's advantage is in the ease of use. The brand image, this can't be underestimated with some companies. How reputable are they? They've got a very good supply chain, and that's going to be hard to compete with. And they've got lots of money. Anything you do, they can do cheaper. So you've got to be aware that they can either buy you out or just undercut the market and kill you. What are their weaknesses? Limited product range, etc. Relatively high prices, and I'll change that relatively high prices to a straight high prices if you look at their new products. They are very expensive, and that would give you a chance to come in and undercut them. Again, using those AirTags that they've just released, they are $50 each for a little Bluetooth beacon. It'd be relatively easy to undercut them on that one. Whether you can outmarket them, different matter. Opportunities, what are the weaknesses? From the weaknesses, you can pull out the opportunities. These are your opportunities to get in there and do something as well. And of course, the threats. What are the threats to the to your product? Other smartphone makers like Samsung are continuing to eat away at Apple's market share, making cheaper and, in some cases, better products. Certainly, technically, they're better, but they're not quite as easy to use. And of course, COVID, the wonderful COVID, that's affected everyone. All right, so just a heads up next on, let me get to that, week 4 tasks, because we may not see some of these people, particularly the people this evening, until some of those week 4 tasks are close to being needed. You should have joined a topic team and posted the idea in the topic discussion board. If there's not enough people in the topics, we will move people around a little bit and try and get people into related areas. We should have enough students. I think there's about 50 students in this run to have a good range of topics. So we'll sort that out probably this week, I think. Give some feedback to your fellow students. Start talking to them. Really important to get that peer support. Make sure you know which group you want to be in. We were considering not having the morning one because people weren't turning up, but it certainly looks like there's enough people to continue this. So at this point, I would say we will continue. Watch the product development videos. These are done by the gentleman who I hope will come in and talk about commercialization later on in one of our later, probably last couple of weeks, I think, of the course. And populated your Canvas template and submitted the link. Can you remember exactly what date that's due, Savash?
I think we set it for the end of this week, but I'll just double check the final date.
So that's coming up very soon. That's the first grade assessment and is worth 10%. So we managed to cover everything there in just over half an hour. So now it is time to start discussion. So I'll just stop sharing my screen.
So Ian, we had a question in the chat from Anne. She was asking about load cells, force sensitive resistors, and other stuff. Anne, please feel free to unmute your mic and you can ask your question.
Sure, thanks. Can you hear me?
Yep.
Perfect. So I'm looking to build a sensor that detects when a bird feeder is out of bird seed. And so I was looking at a couple different kinds of sensors to do that. And my initial look at load cells is showing a lot of really expensive, kind of like way too accurate for bird feed kinds of sensors. And so I was trying to think of what other sensors I might use and force-sensitive resistors was one of the types I was going to play with, but I don't know that that's going to even pick up like the weight of the bird food. And so I was wondering if there were other ideas for what kinds of sensors might work here.
Ian, I think you're muted. Yep.
It does suit that as soon as I stop sharing the screen, I forget.
Yeah.
Is your bird feeder on a sort of hanging from something? Hanging from an arm or?
Probably. So you're thinking measure it there.
Well, measure it there, or if it's on an arm. Okay. So if it's on an arm and you have the bird feeder hanging, this is trouble these backgrounds.
Yep.
And you have the bird feeder hanging down off an arm, you could use a flex sensor. So it would measure the flex as the arm bends, or you could put a flex sensor, strain sensor on the chain that's actually hanging. And that way you could also add it so it can count the number of birds that come and land and feed from the feeder. So it can give you feedback on that as well. It could also tell you the weight of the bird and anything else that you want to know about that particular bird. But load cells, yeah, they're aimed at industrial scales and being extremely accurate. You would be much better off using a capacitive pad if it's sitting on something.
Yeah, I'm looking at those in so those FSRs, force sensitive resistors. I think that might be able to pick. So you want to be able to tell when the berser is empty, so you can put more seeds in there, right?
Yeah.
Is that the idea?
That's the general idea.
Yeah. And how much seed would be there? An ounce, 35 grams.
The feeders vary a lot in size. So the idea is that you can add this to your existing feeder instead of having to buy one. And so that's why I was thinking something that went under the bird food might work. So I think the smallest ones I've seen are probably like 10 or 20 ounces, and then there's some that are much bigger.
20 ounces, that's 700 grams. Yeah, that shouldn't be a problem putting it in at the bottom of the feeder.
Yeah.
And if you concentrate on looking at the change in value rather than an absolute value.
Yep.
Yeah. So you could, when you install it, you press a button and say, right, it's empty, and then you fill it up.
And I'm just checking the range.
Exactly.
Yeah. You could then rate it.
Kind of calibrate it.
Yeah. So you don't look at change. And that way you need to get down to 0. You could just say, we've got 20% left, because it'd have the empty and full measurement. So you could just do that as a percentage. You could then give them more information, like it looks like it's going to need filling up in 3 days' time.
Exactly.
Yep.
I think this looks good because I'm looking at the range, and I've worked with these before. Yeah. They're fairly simple to use as well. You just pretty much need a resistor in one of the pins, and then you can connect it up directly to an Arduino. And yeah, this looks interesting. And one more thing while I'm sharing the screen might be useful to show you guys. I've been looking at this M5 stack, which is an IoT development platform. So there are lots of these types of devices out there, but this specific one, it uses an ESP32, and there is this modular design where you can get the core where it has the ESP32, and the reason people are using ESP32s in lots of IoT devices is that it has an embedded Bluetooth and Wi-Fi chip on the micro, so you don't have to worry about other interfaces with your microcontroller. And there are a number of ways of programming it. You can even use Arduino's programmer. And if you don't have that much of a technical background, there's even a visual programmer where you can just get phrases and connect them up to each other. Might be interesting to have a look at as a potential platform for your IoT device. If you just wanted to go beyond just an Arduino, for the implementation, because when you start looking at solutions and you start thinking of your platform, you'll see lots of Raspberry Pis and lots of Arduino implementations. But once you get into it, you'll see there are a lot more interesting platforms that you can use. So I thought I'll bring that up, and I'll share the link to that. And we'll have a seminar later on that will have a more in-depth discussion about what type of sensors you use, how do we usually interact with them, how do you go from a prototype to an actual product, but that's coming later on. Hannes has a good suggestion in the chat. He says, one thing to consider is that you're going to get some error from additional weight. Another approach is to use the sensor in a large scale to pick up feeding birds. When no more birds are coming in, it may be time to either refill, feed, or clean. Yeah, that's a good idea.
Yeah. You could even build a camera system into it so you get photos of the birds.
Yeah.
Great for bird watchers.
And an app that shows.
And now it's too complex.
You'd be surprised how simple it is to actually build a camera in. Little micro-controlled cameras which would then wirelessly transmit a JPEG. They're actually much simpler than you think. Most of the work is done for you.
Yeah, I thought about that initially, and when I was looking at other companies that are doing something similar, they all have cameras and they're all having a hard time getting to market. So I thought that might have been the complexity factor.
It probably is, and it's also, you would need a higher level processor, of course, which pushes your price up quite dramatically. Apple once released the information on why they cut down the number of interfaces on their laptops, and it's really a silly excuse, but that's what they're using. For every additional connector they put on, which may only cost $1 for the connector, it adds $100 to the end price of the device. And that is because of the design cost, the changing tooling and having to put an extra port in, and all of the add-ons. So if you add a $10 camera, you're not adding $10 to the cost. You're adding a very significant amount to the cost. Okay. How about we do a quick round table and everyone just introduce themselves, say what their project is, if they have anything in mind. If they don't have anything in mind, then we can have a bit of a chat about different ideas, things that suit either your work or hobbies or other things. So you've got a list, Sebastian, you want to run down?
Yeah, sure. So I'll go from the top.
If you want an introduction to us, it's in last week's video. Yeah. But each of us here have got Sebastian and I have very similar, but we've got people who are specialists in individual areas. So you should be able to catch that from last week's. Sorry, go on.
No worries. So Alistair, you want to go ahead?
Hey guys, so I'm a solutions architect at a utility here in Western Australia in the corner from Curtin Uni. Strong background in network engineering and RF, and the IoT project I'm looking at is a change of state tracking system to enhance like fixed plant isolation. The whole idea here is if someone's trying to shut down a piece of equipment to work on it, they can verify with some automation that all the valves are shut. Now, this is a very, very critical thing, especially for working with oil and gas plants. So I want to think of a way to make sure those valves are shut from the back end and tie that into an isolation system.
Good to see you again, Alistair.
Okay. Andrew, I think we had an introduction from you last week, but if you wanted to just let the other people know what your idea was for your IoT device.
Yeah, sure. I didn't join the seminar last week. We had a quick chat.
Oh, right.
A separate chat.
Okay.
So Andrew, I actually run an IoT as a platform company, or IoT as a IoT company. We're working on a use case, which is he's working on a number of use cases, but the one that I'm looking at for this is around a tracking solution for vulnerable people, so people with autism, dementia, things like that, and adding some additional features in that are not available within existing solutions.
Okay, thank you. All right, Anne, so we know about your bird feeder. Would you mind giving us a bit about your background?
Sure. So yeah, you've heard about the bird feeder. I do have a number of bird feeders in my yard, in case you were curious, and my neighbor has an incredible collection of bird feeders. And so I've got a whole bunch of bird feeders to practice with nearby. My background is mostly in DevOps recently, although I've been moving more towards data analytics and machine learning, and I'm a software consultant for a large public cloud vendor.
Okay, good.
Good to meet you.
I got lots of birds in my backyard, but I feed them from my fruit trees.
The deer seem to get the fruit trees.
We don't have deer here, only kangaroos.
And droppers. So, Jaime, you're next. You want to give us a quick introduction? And I think your microphone is muted. Okay, so I'll just jump ahead for now. So, is it, sorry if I'm butchering the name, but Carlos Garrido, would you mind going next?
Hi, are you hearing me?
Yep.
Okay. I work in automation in a coffee factory here in Colombia, and I am planning to work with some IoT devices, and so we can connect in our factory some old counters like electrical counters and water counters, and I want to connect some old protocols like serial or I don't know. I just was thinking about optical recognition characters with a camera to read the old counters that work with analog types of counter. I'm just looking for something like that. I don't know if you know some devices that do that.
Strangely, we do. The water meter counter that we just got.
Yeah.
We'll send you a can you dig it up, Savash, and post it? Australian water meters are the old rotary mechanical dial. Is that the sort of thing you want to read? So they have like the old speedometers in cars. They have the numbers that click around.
Yes,
yeah.
That's mine.
We've got a student, honor student, working on looking at water meters, and part of that is going to be reading the that old display. And it was DFR Robots that had it, or DF Robots. Yep. They've produced a little kit which will read those dials using machine learning and convert it into a digital form. And it was pretty cheap, I think, from memory.
Yeah, this was the AI vision sensor thing that recently got right. It is just 82 Australian dollars from this particular vendor, but
yeah, you'd build it for
sure we can.
But even at $82 for a factory, it's not overly expensive. You can pop the link.
Yeah, I've posted the link in the chat.
I thought it was DF Robot.
No, I think it's a different company, and then here's a YouTube link that's using the device with a Raspberry Pi. Oh yeah. Oh, okay. There is the sensor itself. So the
that's not what I was looking at.
Yep, I've got the other one. That's the DF Robo one in the chat. That one is $54 from. I think that's the module. Yeah, that's the one.
Yeah, we just got that in, so we can actually let you know how that's going. But it's specifically to read those type of digits, and there's lots of videos and things on how to set it up.
And we actually just got another Australian company. So Ian Brad sent that to us. That I just saw it, but they're called Optical Advanced Metering Infrastructure. You might want to take a look at the company as well. So just to give you some ideas, I posted all of those links in the chat.
Excellent, excellent. I will check then.
Yeah,
Okay.
there is another one I was thinking of, which I'll have a look for, and
those AI chip from
yeah,
Seed.
no. This was an actual implementation of reading the water meter.
Yeah, that's the YouTube link that I've sent.
Is it? Oh, okay. Sorry, I missed
Yeah.
it. Oh, there. Yes.
Okay, thank you.
No worries. All right. Robin, you want to tell us a bit about your idea?
My name's Robin. I'm a product development engineer here in the U.S. I'm looking at coming up with like a initially be like house plant monitoring, but based on, because I was at the last morning session, we had some back and forth about that to add in some more general atmospherics, like humidity, CO2, and then just looking at basically having a device. I know they're pretty common to stick into the soil so that you can measure the all the basics for a plant, and then where we would take it as the next step further is with the notifications, and then potentially some automation with watering, and then also just just with the alerts and everything. So
Okay, good.
We have one person. So Jaime Hernan, would you mind giving us a quick introduction?
Okay.
Yeah.
Hi, good evening. My name is Jaime Hernan. I work in Buen Café Refrigerizado, the same that I collect Juan Carlos. Excuse me for my English. This is very slow, irregular. And I think to work in those projects. Decision one. The first is use IoT sensors for measure temperature and export the signal for one page inalambric for maintain information all time at the one cool room in installing my factory. Yes, for measure the temperature the extract, the coffee extract all time and maintain the all time the same temperature, the temperature freezer. Yes. Other project is installing one farm for measure the humidity and temperature. The same export the signal inalambric to the base and maintain the the signal information all time.
Okay, great.
I think that do project and take the decision for one. Yes.
Okay, good. Okay, we've got 5 minutes left. Has anyone got any specific questions they would like to ask?
Yeah, feel free to use that. If you hover your mouse over next to your name, you'll see a raise a hand button. Oh, there we go. Robin, would you mind going ahead?
I was just wondering how the teams are going to work and with the assignments? Are we doing all our assignments individual or?
It's all individual, but the teams are
Okay.
there to support and get expertise from other areas, other people, if that's applicable.
Okay, all right.
And if you do get something from someone else, yes, go ahead and use it, but just acknowledge that you got this from whatever source you actually got it from. Any other specific questions? All right, well, we'll really quickly run through the instructors that are here, as we did last week, save you having to go back to the other video. We'll just very quickly say what we do. I'm Ian. I'm the Deputy Head of School for Electrical Engineering, Computing and Mathematical Sciences, or as we call it, everything that doesn't fit anywhere else. My area is embedded systems, networks, IoT, things along those lines, particularly in the health and rehabilitation engineering fields. We'll just go across the top. Savash.
Sure. I'm Siavash. I'm a lecturer in electrical engineering, same department as Ian. And so all of his areas and my personal research is in human movement and looking at hand movement and wrist movement of children with cerebral palsy. And I teach a lot of embedded system, digital design, and small electronic units dealing with microcontrollers, FPGAs, IoT platforms. So if you had any specific questions in that area, you can use the IoT capstone email and reach out to me.
Yep, and when you use the IoT capstone email, it helps if you put who you think would be best to answer your question in the subject line, and then they'll go straight to it. And if it's not them, we'll find the answer somewhere else and point you in the right direction. Hannes, our algorithm guy.
Yeah, I'm Hannes, the algorithm guy. Hi. Background in logic, bit of AI, although not deep learning so much. I also know a bit about databases and related things if you've got questions about that. I'm a lecturer from computing, which is the same area as these two gentlemen.
Okay, and we've got Yuffie hiding in the background.
Hello, everyone. Sorry, I don't have a camera for my main computer. I'm also a lecturer, and my main research background is about the wireless communication, but I also have experience with programming and microcontroller sensors, and I'm trying to make an IoT lab at Curtin University with the help from Savash and Professor Ian at the moment.
It's an industrial IoT lab, so we're looking at interfacing PLCs, some of the old protocols which were mentioned here earlier, such as HART, wireless HART, Modbus, CAN bus. So we've got an experimentation area and also a teaching area. There's two people who aren't here at the moment. Got other teaching commitments in the morning, but they're crucial to the support side of things. First one is Dr. Valerie Maxwell. Can never get that quite right. Anyway, Vel. Vel is our gun Python programmer, big data, machine learning to a certain extent, but predictive analytics definitely person. So if you have a programming issue, Vel is the go-to person. And David McMeekin, another lecturer in the computing area and also a bit in the electrical. He's a software engineer by training, but deals mostly in location mapping, geographical information systems, and is great if you're looking at location information to be included in your IoT project. He's also our iOS developer, so if you're looking at iPad, iPhone development, he's the guy to go to for that one. We've got lots of other people we can call on if need be. Luke for data science side of things and many others. You just need to let us know what your question is about and we'll find the best person to answer it for you. We're a fairly large school. We've got 170 staff, I think.
70.
Very big in astrophysics, so if you were doing something in astrophysics, we can help there too. But a very wide range of skills and abilities. So don't be shy, ask, get your value out of the course.
And
all right.
Before we wrap up, Ian, I just want to ask everyone, if you haven't already, please make sure to submit the proof of clearing the previous modules on the edX platform. I know there were some problems with the link in the first week, so we've fixed that. So if you haven't already, please make sure to submit your credentials so I can confirm. Thank you.
All right. So we'll wrap up now, and thanks everyone for turning up. Nice to meet the new people. Don't be shy. Keep in touch, and we'll see you in 2 weeks, and I'll stop the recording.
Thanks all.
Ciao.
Thank you all.
Thanks so much.